Thank you, ladies and gentlemen. It's an honor to be here. And without taking too much of time, I would like to begin immediately. Which one is it? Excuse me. Which one is it? Not yet. Okay, I would like to begin. We are going to be discussing the emerging trends for GIS mapping and survey by UAVs. And as Mr. Srinivasan has already given a very detailed description of the various types of UAVs and the payloads and the regulatory aspects of it, I'll try to be slightly different from Mr. Srinivasan. A little bit of introduction regarding Cadet Defence. The company was formed in 2005, and Cadet was the first company, private sector company in India to supply unmanned systems. And when I say unmanned systems, it does not mean UAVs. It means pilotless target vehicles, which are autonomous aircrafts that simulate a fighter plane for target practice. So we were the first companies to win an unmanned contract with the government of India. Now Cadet is moving towards UAVs, which are going to be primarily used for the survey of, for GIS mapping, survey of oil and gas industry, agricultural inspection, education, etc. And we have floated a new company called Cadet Air, which is basically going to be dealing with civil commercial applications in the UAV domain. These are some of our existing products. We have two aerial target systems. One is the JX4 and then the Javelin right below it in yellow. And then on the right side you can see the Garuda 100 NEO and the Firebee. And we have one more system called the Silver Bee, which is exhibited outside. This is our latest entry into our line of products, and it'll be the Silver Bee that is going to be extensively used for GIS mapping. Now, when we talk about UAVs and mapping, we should understand that we are talking about small unmanned aerial systems. As very clearly indicated, that regulations do not allow large UAVs to be flown above a certain height, and that height is restricted to 400 feet by the DGCA. So we can assume that the only UAVs that can be used for GIS mapping will be the small unmanned aerial systems. Now, the technology has gone so far ahead that the sensors that are used for GIS mapping have become extremely light. So it is possible for small unmanned aerial systems to carry very powerful sensors that can produce accurate and detailed maps for use. And these are also 3D maps. That is the biggest advantage. Today, small unmanned aerial systems are able to provide 3D maps, which was not possible some time ago. Now, I'll very quickly go through the civil UAV applications. UAVs can be used in multiple sectors, starting with the government, where law enforcement, border security, Coast Guard operations can be, and other MOD operations. UAVs are extensively used. Then in the civil side, you have agriculture, forestry and fisheries, where you can monitor, do environmental monitoring, crop dusting, and optimizing use of resources, natural resources, by monitoring mines, by monitoring inland waterways, etc. And I would like to further add that in the crop dusting arena, Japan already has around 15,000 of these UAVs in use. So, and this is a pretty old story. It is not a new story, what is happening in Japan. Then UAVs are used for firefighting. In the US now, UAVs are going into forest fires to study how these fires have started and what can be done to extinguish them. And they give real-time analysis and surveillance of the forest fires spreading or contracting, etc. Then it can be used for emergency search and rescue operations. Then you have the energy sector, where a very detailed slide regarding the monitoring of the electricity grids has already been done. Then UAVs can be used for earth observation, remote sensing, communication and broadcasting. Now any low-level observation or data collection is a business opportunity. Now who are the major stakeholders for GIS mapping? You have the end customer. The end customer can be various agencies, including the Survey of India. It can be agencies such as the the Ganga Action Plan Committee, which wants to do a GIS mapping of the entire riverbank system. Or it could be the Indian Railways that needs to do a detailed GIS mapping of the new trains that are being put up, such as the bullet train. Then you have the UAS operator. The operator is the guy who plans the mission, controls the mission and executes the mission. Then you have the UAV manufacturers. Sometimes the UAV manufacturer and the operators are rolled into one, or the operator may source a vehicle from a manufacturer and stick purely to operations. Then the most important aspect, which makes it very exciting, is the data processing, software and services. All the information that you gather has to be analyzed and interpreted properly. Now, Cadet's principle for success is cost, endurance and indigenous. All our products, all our birds are designed in-house, and these birds we claim that have a higher endurance than the ones available in the market, and because it is indigenous, the cost is also low. And Cadet serves as an end-to-end solution for GIS mapping and surveying activities. Now I'll give you a slight price difference and performance difference between a full-scale aircraft and a UAV. The UAV we are talking about is a Terex UAV, and so if you look at the flight duration, a full-scale aircraft has a 2-hour flight duration, and a UAV can also be operated for up to 2 hours. Now in a full-scale aircraft you have 2 pilots, typically with bi-engine qualifications, and in a UAV operator you have 1 pilot and sometimes with a helper or an observer. Now naturally an aircraft is flying very high above the ground, so the area of coverage is much larger due to the line of sight, which is much better. Now in the UAV, that area of coverage is lower. It is around 9 square kilometer when you are flying at up to 300 meters. The resolution as a result of being closer to the ground is much higher than in a small UAV. It can be up to 4 centimeters per pixel at 100 meters and 11 centimeter per pixel at 300 meters. Now as far as the cost is concerned, the small unmanned system is 10 to 200 times less capital intensive. It takes an enormous amount of money to acquire an aircraft, train the pilots, pay for fuel, and of course the service, maintenance and parking requirements cost an enormous amount of money when you compare it with a UAV. The noise limits are quite high in an aircraft, whereas a UAV is completely inaudible about 200 meters. You can barely hear it. An aircraft must return to its airfield, whereas a UAV can be stored in a backpack next to the operator. So we feel that for GIS mapping purposes, where the height of operation is below 400 feet, a small UAV should be the preferred system. Now let us talk about the differences in resolution versus an aircraft that is flying at 1,500 meters against a UAV, small UAV that is flying at 300 meters. Now if you look at the image on the left, you can see that there is a green haze, plus there is a lot of noise as a result of shadow and other and height related issues. But if you look at the image on the right, you can see that there is much less air between the sensor and the target, and the resolution is the same but significantly better color definition. That is to say that you have more information per pixel, and when you have more information per pixel, you can work with the image a lot more. You can expand it, contract it as per the end user requirement. Now this is the difference between a satellite imagery versus a UAV. Now in satellite, what happens is a satellite has to go around the earth multiple times, and so it has to cover multiple swaths to gather an equal amount of information that a UAV will gather versus flying flat on top of the target area multiple times. Now a satellite is also not on demand. You can't call in a satellite and take pictures. You have to time it and then do it that way. Whereas a UAV is there on demand. And in satellite imagery, generally you collect the data and then you process the information, you get the images out and then go about cleaning the images. So if you see the left hand side image, there is a B-52 bomber that is in between the aircraft taking the image and the houses or the neighborhood below. Now whereas if you take the same aircraft with a UAV, you can delete that picture even before the image is processed. So here we are talking about how much you can work with when you take imagery from a sensor based on a UAV. Then you have some more examples here. If you look at the top image, you have the cloud cover that is blocking the terrain below, whereas a UAV can fly below the clouds as it is flying only at 350 feet. So that again is an advantage. Now this is some of the products from Cadet Defence Systems fleet. We have the Silver Bee UAS which was launched recently, and it's a UAV that weighs about 3 kgs and can carry a 750 gram payload. And when I say 750 gram payload, you can even put fused sensors in it. Fused sensors are new technology sensors wherein you can superimpose two kinds of images. You can have an IR image superimposed on an electro-opto image. So you can study an industrial facility much better. You can see where the pipelines are going, or if there are any pipelines hidden, etc. Then of course we also have the multi-rotor, a quadcopter for specific mapping requirements. Our fleet demand is based on user requirements also. If there is a particular UAV that is required for a specialized product, then we can design a UAV specific to that task. This is the Silver Bee that you must have seen outside, that is placed in the stall there. And very quickly I'll go to another product of ours. This is the multi-aspect ground image capture. Basically this is an end-to-end solution. A real estate company such as DLF or L&T or Mahindra can come to us and they can say, look, we have a 10-acre size plot in an industrial park. Can you provide us the imagery for that? So we can do an end-to-end solution. We can plan the mission. We can monitor the mission, and of course put the effective controls that are required. And after the data has been gathered, we can process the information into the exact kind of resolution and imagery that the customer demands. Then we also have the Correlator 3D image processor. Basically, we feed in all the data that has been collected by our UAV flights, and this is the software that does the analysis of the data that is gathered. So I'll very quickly breeze through this. Now, the business model of Cadet is rent a pixel. Today, rent a pixel is the model that is being used in the West, where GIS mapping using small UAVs has almost become the norm today. So rent a pixel means basically a end user will come and say that I just need an image of this target area, that is it. After that, it is the job of the UAV operator, a contractor, to provide the necessary information via pixels. Then the second model is information service provider. That is again an end-to-end solution. Apart from taking the information and providing the pixel, we process those pixels and we get the data out of those pixels and we analyze as to what's going on in that image. Now, we are also looking to go into the precision agriculture. If you look at the image on the right, that is a image taken by a hyperspectral camera. What is hyperspectral imagery? This is actually now in vogue in the West. A hyperspectral image is basically a chemical signature image of the target or the ground below. So it is the refractive index based on the various spectrums that gives the image analyzer an indication of what is present in the ground below or on the object below. So in this case, the crops can change color, emitting a certain spectrum of light, so which gives the agricultural planners on what is the next step to be taken vis-a-vis crop rotation, feeding fertilizers or putting in more water, etc. Then all these images are geo-referenced and stitched. Our UAV can cover an area of 1 square kilometer in 30 minutes. And then again, this kind of imagery can be used for pasture and grazing management, feed bunk aerial survey, and animal health indicator. Now, there is another unique application that is now being worked on is the solar panel inspection. Just as in the previous presentation it was explained, how to look at the corona in a transmission line. Similarly, an IR thermal image is taken of the solar panel below, and anomalies, that is changes in thermal patterns, are detected on each cell. And then you can get a clear indication on which cell exactly is causing the problem. Now, solar, usually this is done manually, but as the solar parks increase in size, we will have solar parks which are almost 1,000 acres in area, and it will take a hell of a lot of time if someone were to do it manually. So UAV is the way to go. And even in wind farm monitoring, today the cracks on the blade or certain damages, obvious damages, UAVs are the way to go. And UAVs can be used for gas pipeline inspection. It can be used for, of course, the power line transmission inspection also. Then our water resources minister had recently said that she would like to clean up Ganga in a month. Well, that's easier said than done. but at least the use of UAVs in choke points. Choke point is the point where all the dirt and urban sprawl gets collected and accumulated. I think GIS mapping for this purpose would be the way to go. It can give detailed maps of where the choke points are, where exactly a construction activity needs to be done, using precise mapping techniques. So this is something that all UAV companies should look forward to and petition the government perhaps. Regulations is the need of the hour. Like I've said before, GIS mapping involves small UAVs that can be flown below 400 feet. I think if you take proper permission from the authorities, that is the police, the district magistrate of a particular area, and inform the airport, GIS mapping today is a doable proposition. It is only when you go above 400 feet, or if you're going to fly near an airport or a building of importance, security importance, people will have problems. But I think if prior permission is taken, and if it is a government project such as the Clean Ganga program, or GIS mapping for the railway projects, these permissions can be availed without too many problems. That is what my hope is. So thank you for bearing with me, and have a good day.